Hi class, today we're going to be looking at the formation of the solar system, the process that is believed to have happened to create the solar system, and a little bit with the Big Bang Theory and the universe. So first, just a little history on astronomy. If you're taking notes, writing these down, you don't need to write this particular slide down. Just kind of gives you a background. So the first record of the study of astronomy was in Egypt. There were a group of stones that were arranged to line up with the sun on the longest day of the year, which is called the summer solstice. And then Stonehenge, England, one of the world's oldest observatories, the stones are aligned with the winter and summer solstice. Okay, so moving on to a key definition in this section is the universe. And this really sums up everything. It's an all-inclusive type of definition. It's the sum of all space, matter, and energy that exists, that has existed in the past, and that will exist in the future. So there is only one universe. Inside of this universe, there are galaxies that hold millions of stars, and we are located in the Milky Way galaxy. Just to kind of point out, a lot of people assume that in the Milky Way galaxy that this is our sun, and then we're rotating around that. But actually, in the Milky Way galaxy, we're just in one of those little rings, and so the sun is out here, and you can see that here. And then we're orbiting the sun in this location. All right, so kind of give a little bit of history of how scientists have looked at our planet compared to the sun and other planets. The first models of our solar system had the Earth in the center, which was called a geocentric model. Scientists and individuals were always trying to figure out kind of where we fit in this bigger scheme. And so the Greeks were the first to try to determine Earth's place in the universe, and then Aristotle used math and models to illustrate the universe. Kind of coming along a little bit later, Copernicus was the first to put the sun in the center of the solar system in 1543, and he called this heliocentric. At the time, he wasn't really believed, and he explained that the Earth and other planets orbited the sun in perfect circles. Now, a couple key things here, this term heliocentric, you'll see that again. And also this portion here, to know that Copernicus said that they orbited in perfect circles. We'll find that that's not really true. But you do need to understand kind of what he said in our timeline of things. Kepler came along next, and so we have Kepler here, improved on the Copernicus model, and he said that the orbits are actually ellipses going around the sun. At this time, there was no mathematical proof, so again, people were kind of sketchy on him, thinking, well, I don't really know if this is true. And so along came Newton, which we've done quite a bit with Newton in this semester, and he explained gravity. So with this explanation, with some mathematical explanation, people then understood a little better that the orbits were actually elliptical, and he helped explain why planets traveled in elliptical orbits. He explained that every object in the universe has a gravitational force on every other object. So every object is pulling on each other, basically. Larger objects have greater gravity, and smaller objects have lesser gravity. So realistically, or theoretically, I guess you could say, if you were out in the universe far enough away from everything else, you do have gravity. So there would be tiny little dust particles or something that would orbit you. So larger objects have more gravitational pull compared to smaller objects, and smaller objects that are close enough to a larger object will orbit the larger object. Here's an image of that. All right, so getting into how the solar system formed, the most widely accepted belief is the nebular model, and this is on page 648 and 649. A couple key terms you need to know. Nebula is a cloud of dust and gas in space, and this is where stars are born or possibly explode. According to this nebular model, the sun and planets formed from a nebula or cloud of gas and dust that collapsed because of gravity. So our steps in the nebular model, you don't really need to write all of these things down. I kind of give you a couple things that you can put in. Basically, we have a nebula that collapses due to gravity. So all this dust and gas basically comes in, it's attracted to each other based on gravity, and eventually it just kind of collapses in on each other. This begins to rotate because of the energy that's in each of the particles, and it gets warmer near the center. Now at step 3 we have, and really step 1 and 2 are kind of A there for you. So at step 3, these things called planetismals, which is just a collection of gas and dust that's not large enough to be called a planet yet, begin to form. These planetismals begin to collect dust and gas, and I call this the snowball effect. So think about a cartoon where you have a tiny little rock at the top of a mountain of snow, and it starts rolling down the mountain, and eventually it continues to collect snow and more snow and more snow and more snow. And as it gets to the bottom of the hill, it's this huge boulder of snow that's rolling down the hill, collecting everything along its way. And that's kind of the way that I think of it. It's called accretion when we're talking about it here. But you could also kind of refer to it or put a definition next to it as the snowball effect. So these smaller planetismals collide with the larger planets, causing them to grow. The remaining dust and gas are eventually removed because it's kind of collected into this based on accretion. And so we have, in the end, planets that are going around the sun. And this is when you have a new solar system. You do have some better pictures in your book. Again, page 648 and 649. All right, so our universe. How did our universe begin? The Big Bang Theory says that all matter and energy in the universe was compressed into an extremely small volume that exploded and began expanding in all directions. Now, how do we know this is true? We actually have some good ideas of why scientists believe that this is how the universe began. Red shift and blue shift, or the Doppler effect. So we studied the Doppler effect with sound back in chapter 14 and 15, and the Doppler effect is based on wavelengths. If something is moving towards you, the wavelengths are shorter. If we're talking about sound, then the wavelengths are shorter, and so it is louder. If the wavelengths are longer, moving away from you, then it is quieter. So when we're looking at light, longer wavelengths are going to have a red shift. So this is kind of our key thing here. Red shift is going to be longer wavelengths. If you look at the electromagnetic spectrum, red has a longer wavelength. Shorter wavelengths are blue shift. So red shift would tell us that something is moving away from the observer, and blue shift would tell us that something is moving toward the observer. Sorry about my lines here. Okay, so our universe, based on the Hubble telescope, we've been able to observe this. Our universe has red shift, so it's believed to be expanding. If it's currently expanding, you would assume that at one point everything was much closer together. And so that idea allows us to kind of come up with this Big Bang Theory, that everything was once closer together and it's expanding, continuously expanding away. Okay, that's the end of our notes today, the introduction of the universe and solar system.